Jason Gorman, I just mentioned his name. He's a well-known speaker, thinker, expert, and he just told me that his last keynote he did was right here at JAX, and that is really an honor for us. So please welcome Jason Gorman. Jason.
You lucky people. First in-person conference in a long, long time, and you are now going to have to suffer me for the next 30 minutes. So well done. You made a good choice. Okay, so Sebastian approached me earlier this year about coming and doing a talk at JAX, and he was inspired by something I'd posted on social media I was boasting about how quickly I can learn programming languages. It takes me just a few days, really, to learn the 20% of a new programming language that you would probably use 80% of the time, which is very, very different to how it used to be when I started programming. And I thought a little about this, and I thought that's probably a very narrow topic for a keynote. So I wanted to expand, really, on the whole question of learning as software developers. So I came back with a counter proposal, which is the talk I'm about to give you. I don't think there's anything especially controversial in what I'm about to say, but we'll see. A lot of this is stuff that you might nod and agree with, but we'll ask the question at the end, if most of us agree with this, why don't more of us do it? But let's get into it. So what I'm going to be talking about for the next half an hour, first of all, we're going to look at the traditional view of software development teams as vehicles for delivering software. Hopefully nobody disagrees that that's what software development teams do. But I'm going to flip that around and look at software delivery as a vehicle for growing development teams. So same activity, but a different focus, a different emphasis. We're going to talk about stable teams or long-lived teams and ask the question, are they the real product of software development? And then we're going to get into some of the details. In particular, how do we keep our best developers, our most experienced developers, doing what they do best? So we're going to talk about alternative career paths for software developers that keep them software developers. We're going to talk about how we can avoid stagnation. I've worked on long-lived teams that were not very, very good, did not learn very, very much. So how do we avoid getting into a situation where your team essentially just stagnates, doesn't learn, doesn't improve, doesn't evolve? And then finally, I'm going to briefly paint you a picture of a team-powered business, a business that is made up of software delivery teams that are long-lived, learning, growing, and evolving. So let's look at the traditional view, teams as vehicles for delivering software. For all our talk of agility and continuous delivery and a product focus, the dominant paradigm in software development today is still projects. Projects, project teams, and project deadlines. It's all about hitting that next release. And in that view of software development, that has implications for the way that these organizations view their software development teams. They don't view them as human beings, as learning, growing, evolving individuals or groups of individuals. They view them as machines made of interchangeable parts, cogs, that can be swapped in and out. One Java developer is pretty much the same as any other Java developer. And when you look at teams that way, it's easy to fall into the trap that one team is pretty much the same as another. Similarly, with our view of the software delivery process being all about creating software, creating working software. In many organizations, there's no real acknowledgement that teams can grow, that teams can learn, that the process of delivering software requires us to learn new skills to improve our processes and improve the way we work and grow as a team. So in many organizations, the software is seen as the primary end product, And the team is kind of a throwaway thing. I put some exciting transitions in, by the way, just in case you get bored with what I'm saying to you. So look out for those. Let's flip the picture around. Let's not look at teams as vehicles for delivering software, but as software delivery as a vehicle for growing teams. So now we can focus on the long-term capability of our developers and our teams. So if you're familiar with Scrum, you will have noticed that there was a very important feedback loop missing from that previous slide. That's the loop where when we've delivered the working software, we review what we did, and then we learn and we build those learnings. We retrospect on how we're working and try to improve how we work in subsequent iterations of the product. So while we're building software, we're also building software development capability. This is a very different way of looking at it. Okay? Now, I'm going to argue in this talk that the real end product of software development is software teams, the most valuable end product. I'm aware of the fact that many organizations out there see software teams as a byproduct of doing software development. I'm going to argue in this talk that software is a byproduct of growing software teams, of building capability. And it is that capability that has the most value, is the real, true end product. Software development is a risky business. We don't like to admit it, and managers in particular and investors really don't like to admit it. But 95% of new software products fail in the market or fail in the business. They don't deliver the rewards that the investors were hoping for. 95%. And that means that 95% of the time what we're left with is a failed product and a development team and what they've learned from delivering that product, from creating that product. In other words, 95% of the team, the thing you're left with that has value is that improved capability within the team. 95% of the time. On average, the most valuable thing that is created by developing software is the team that creates it. On average, it's the most valuable thing. So it's interesting that most organizations are quite happy to throw the team away after they've got their failed product, because teams are just interchangeable parts, cogs in a machine. One Java developer is pretty much the same as any other Java developer, but we fail to acknowledge the true costs of building teams and, more importantly, the true value of high-performing teams. So let's talk about a different picture of teams. Let's talk about stable teams or long-lived teams. Are they the real product of software development? So here's the traditional view of software teams: project-focused, release-focused, deadline-focused. You get your first release, and then because teams are viewed as a fixed cost, they're viewed as a liability to be minimized as soon as possible. What many organizations that are very project-focused will do is they will get rid of as many of those developers as they can. They will disband the team. They might keep one or two junior developers, the cheaper ones, to fix the bugs and maintain the product. But there's no real acknowledgement that they're going to have to go again. There's going to be another release. So by the time we get to that second major release, the team is very, very different. Very few people are left. It's essentially a different team. If we take a different view, if we think in terms of preserving the team as best we can between those releases, it means, first of all, the team is ready to go as soon as you need them. But it also means that the learning that happened during that first release is retained. That capability, that improved capability is retained. So your second release product team will look very, very similar to the first team, except that they will hopefully be better at it, better at delivering software. It takes time to build a development team, typically 3 to 6 months to build a medium-sized development team. First of all, you've got to hire them, and that's no small job. And then you've got to allow them to form, storm, norm, and get to performing. And this process takes months, months and months. So by the time the team is up and running and performing well, you may have spent 3 to 6 months and a large amount of money before very much code has been written at all, before you get to the point where the team really starts improving. Now, the advantage of stable teams is that you are ready to go. You do not have to rebuild the car to go on your next journey. You just need to take your foot off the brake. You have a performing team. There's no need for the forming, storming, and norming part. You have a team that is performing, and that performance is getting better and better if the team is learning. There are implications in terms of the makeup of the team and the skills of the developers on the team, of course. Again, the traditional view is of developers and people within software development, like user experience designers, database administrators, operations folk, and that sort of role. Often they're viewed as specialisms. So if you're a user experience designer, you can't be a developer as well. If you're a back-end developer, you can't be a front-end developer. If you're a database developer, you can't be back-end or front-end. The problem with these very highly specialized roles, it is very difficult to build teams that last, because you tend to find that people like, for example, web designers are being moved from team to team, from project to project, to do that part of the work. And you very often end up with teams that are formed around the tech stack or around roles, for example. The QA team, the user experience team, the Java team, the front-end team, the React team, and so on and so forth. So building teams around delivering a product for the long term is very, very difficult if everyone is very highly specialized. A better mix of skills is if the people on the team are generalists, that they know a bit of front-end, a bit of back-end, a bit of UX, a bit of database, a bit of info security, and so on and so forth. The 20% that they would use 80% of the time. But the problem with those kinds of teams, when everybody's a generalist, is that they're all what we call in Britain a jack of all trades and a master of none. So yeah, they know the 20% you need 80% of the time, but what about the other 20% of the time where you really do need that in-depth specialized knowledge? So the best skills fit for developers in long-lived teams that are organized around delivering end-to-end products is a T-shape, basically. They are generalists in most things. They know the 20% you'd use 80% of the time, but they're a specialist, a deeply expert in one thing. So a developer who knows a lot about web design, or a developer who knows a lot about databases, or a developer who knows a lot about microservices and so on and so forth, architectures. So that when you need those expertise, those deep expertise people, they are actually on your team when you need them for the most part. And that makes it much easier to hold the teams together. So we aim for what we call generalizing specialists, the T-shaped developer. Once we've built our hopefully long-term stable team for a product, many people recommend a sort of a diamond-shaped, or what they call the 1-to-1 distribution of experience and skills. So you might have 1 or 2 senior developers, a bunch more sort of mid-level or journeyman or journeywoman developers, and maybe 1 or 2 junior people or apprentices who are there basically to learn. That's what they're to do, getting mentored by the rest of the team. Now, if you're constantly forming and then disbanding and forming and disbanding teams to meet project deadlines, your teams will always have this distribution. They will always mostly be mid-level developers. But if your team is long-lived, if it's release after release after release after release, over time, the composition, the distribution of experience on your team is going to change from a sort of a diamond shape to an upside-down pyramid, where the majority of the developers on the team are very senior, very experienced. So the overall capability of the team, what they're capable of delivering, over time gets better and better and better. And that's usually good for a business. But it does present us with a bit of a problem. I was a senior developer 20 years ago, more than 20 years ago now. And if I'd stayed a senior developer, then that presents me with a bit of a career problem and a bit of a salary problem, a bit of a pay problem. Because if I want to go further, have more status, more authority within an organization, and earn more, I would have to, in most organizations, move into something I really don't want to do and I'm really not very good at, otherwise known as management. And this is something that can work against long-lived teams. You take all your best developers and then promote them into jobs they're not necessarily any good at, which means you not just lose your best developers, but you gain some of your worst managers. Okay? So how do we get around this problem? Well, the problem is the standard traditional career track, which is still very much the case in most organizations that employ software developers. So how do we keep our best developers doing what they do best? So here's your sort of standard organization chart. You've got 4 project teams there, and we've got a bunch of junior developers and mid-level developers and some senior developers, and then we've got our lead developers. Now, if you're a lead developer and you want to go further, that means development manager. And as a trainer and as a coach, I meet development managers all the time who really regret having to do that. They really regret that that was the only option they had. They like the money, but they hate the job. They would really much rather be coding. They'd really much rather be on the teams building stuff. Most of us do what we do because we like making things. We're the makers. We're not the managers. So we need a kind of an alternative but equivalent career track. For example, junior developer, mid-level developer, senior developers, all pretty familiar so far. These people work on and within development teams doing development. Once we get to lead developer, things start to change. I've been a lead developer many times, and the one thing that I know as a lead developer is you don't do a great deal of developing because there's quite a lot of leading that needs doing, and a lot of battles that need fighting, and a lot of internal politics that need taken care of. So I'm going to propose maybe a slightly alternative version of a lead developer who might not actually be a lead developer. And many organizations call these people principal developers. They have the status of lead developers. They have authority. They have influence. But they're not necessarily lead developers. They're not necessarily leading teams and dealing with all of those issues. They're on the team, and they're able to influence the team by example. They can set a good example through mentoring, through their own code, through their own work. And then beyond those principal developers, if we really use our imagination, maybe the concept of a distinguished engineer, those people who would be heads of engineering if they didn't mind working in management, but they'd rather not. And we'd rather them still be writing code and still influencing the other developers, especially the junior developers, on a day-to-day basis. What's the point in having people with 20 or 30 years experience and very wide experience and very deep experience if they're buried in meetings all the time and not actually having any influence on what the other developers are doing? And then finally, if you're really, really imaginative, go all the way. Maybe you could have a software developer in the C-suite, on the board, having influence at strategic levels over how software development happens within an organization. There are some software companies that are beginning to do this now, still yet to find its way into other kinds of businesses. So an alternative career track that allows developers to progress up to the level, the authority, the status, and the pay of a chief technology officer, but retaining them doing what they do best. The reason why we hired them, the reason why we want them. We want them writing code. We want them pair programming with other developers. We want them mentoring junior developers and mid-level developers. We want them in the code. That's where they have the most value to us. So an alternative career track for developers there. Now, I'm talking about long-lived teams, and I, early in my career, worked with teams that were very long-lived. I worked on a team for a large retailer in the UK, I won't mention the name, who had mainframe systems with code dating back to the early 1960s. And some of the coders dated back to the early 1960s as well. So I've worked on teams where the average tenure, the average lifespan of a developer on that team was more than a decade. So more than a decade of experience. But there's a big difference between 10 years experience and 1 year's experience 10 times. The people on the mainframe team that I work with went on a COBOL course in the 18th century, I can only guess that it was written, started at learning it then, and that was the only course they ever went on. It was the only book they ever read. And the systems and the code they were working on were the only systems and the only code they ever worked on. So they never actually learned something. So how do we stop that from happening? How do we stop our long-lived teams from stagnating? Well, you need to invest. First of all, you need to invest in good, structured mentoring, not ad hoc, well, you know, Dave kind of helps Steve out occasionally, kind of mentoring. But no, Dave is Steve's mentor. That's part of Dave's job, to mentor Steve, to bring Steve up to standard. Yeah? So mentoring is a big part of this, but it doesn't happen by accident. Don't let it happen by accident. The smartest organizations have some kind of mentoring program in place. It's explicitly there. 10 minutes. Right. Something that many of you may be doing already, things like pair programming and mob or ensembler programming, where developers get together in pairs or they get together as groups. And we find that the organizations that do this, the teams who do this, share knowledge much better and much faster than other teams that don't. You can usually tell teams where they pair program with each other and where they swap around a lot, because everybody knows the shortcuts in IntelliJ. Everyone knows them. I've worked with so many teams where you've got developers on there who've been there for 2 years and don't know any of the shortcuts. And I've worked on other teams where they've been there for 10 weeks, and they know all of the shortcuts, and the reason is because they've been watching some of the senior developers using them. It's a great way of spreading knowledge, of sharing knowledge and expertise, and also a great forum for mentoring. Investing. Invest in books. Put your hands up if the organization you work for has a software engineering library. There's a smattering of hands going up. I wish it was everyone. I wish it was everyone. I wish anytime anyone needed to know something about refactoring or something about test-driven development or something about Java, that they could just go to the engineering library and the book would be there. Training courses. Of course, I'm biased. I offer training, by the way. So training courses can be great, especially as team-building exercises. Very often, particularly if they're very hands-on, like my courses are, they're really great team-building exercises as well. But you can also run your own internal training workshops. If you've got people who've got skills and expertise that they can share, maybe make some time and organize your own internal workshops, your own internal conferences. And talking of conferences, conferences can also be great investments. The good hands-on conferences like Jack's, for example, can be a great investment. All I'm saying here is remove all of the obstacles and remove all of the excuses for learning or against learning. So whenever a developer says, well, I would, but I can't afford the book. Well, but I'd like to, but I can't get the time off to go to that conference. Managers, remove that obstacle, remove that excuse. Invest. Make sure that they have what they need to learn as fast as they need to. Talking of time, hands up if you get regular time, maybe once a week or once a month, regular time to just work on your own thing. Okay, a few hands going up again, so 10% time or 20% time, might be one day or one afternoon a week. I found this to be invaluable. Many managers who say to me, but Jason, think of it, that's 20% of our productivity we're losing from the team. And I say to them, well, look, don't stop thinking of that 20% that you're losing. Start thinking about what you get the other 80% of the time. Teams that have more time to learn improve faster. So focus on the improvement, the capability. Don't worry too much about the time. I generally find with all of the clients that I work with that they should expect to invest in terms of time and money about 25% of their overall engineering budget in learning and things like training, 20% time, that kind of thing. Typically 25%, just for an average engineering organization. That's to be average, by the way. Okay, swapping people between teams. So if you've been on the same team for a long time, maybe, as we say in the UK, a change is as good as a rest. Maybe put them on another team for a few weeks so they can see how that team works, and that team can learn from them, see what they do, what ideas they can bring in. And that doesn't just have to be within the same company or organization. There are many organizations now that are doing what are called craftsperson swaps. Well, they'll swap a software developer with a software developer in a different organization. Again, getting out there, meeting people, going to meetups, going to conferences, getting involved in discussion groups, hearing how the other half live. What do they do at the Jet Propulsion Labs at NASA, for example? What could we learn from them? And what could they learn from us? For example, test-driven development is very, very popular at NASA these days. So stuff they learn from people who are working in car companies, doing payroll systems, filtered into places where they build rocket engines and Mars probes. So swap around, give them a different perspective for a while. And finally, structure. Structure is really, really useful. Not rigid structure. Remember the Agile motto, we favor reacting to feedback over following a plan, but having some kind of structure to what you think developers in your organization and your teams need to know, and what kind of things might they need to learn, so that they don't. I'm an amateur guitar player, and the problem with being a self-taught amateur guitar player is I missed a bunch of stuff. I can't read music very well at all. There's a bunch of music theory I don't know. There's some guitar techniques I don't know. And then I went to a guitar school for 6 months, had Saturday workshops with them, and they filled in a lot of the blanks. You're supposed to know these chords. You're supposed to know what they're called. You're supposed to know these intervals. You're supposed to know these scales. You're supposed to do these exercises. You're supposed to learn these songs. These are part of your repertoire now. So that can be really, really helpful structure. That, by the way, is the structure of the Codemanship Codecraft course. So it's kind of based on the kind of thing I do. But that could be a foundation for a roadmap for user experience design or security or formal methods or whatever it is you think your developers need to learn. But it is useful, I find, to get together as a team or as part of an organization and ask these questions and put these roadmaps together and revisit them over time as the needs of your organization change and as we learn. And finally, maybe make it official. There are some companies, sadly far too few in the UK, who are enlightened enough to offer software developers degree apprenticeships, what we call level 6 apprenticeships. Now, I'm aware that in Germany, apprenticeships are a much bigger deal than they are in the UK. In the UK, we still have a lot of what we call degree snobbery. If it doesn't lead to a degree, it's not a proper qualification. Apprenticeships aren't proper qualifications. But there are apprenticeships in software development, for example, that can lead to a degree. They typically take 3 to 5 years. They're pretty in-depth, and they could be very easily aligned with your own internal learning programs, your own internal structure to bring developers in as apprentices and build them up over the long term. They can also serve as a useful incentive to not leave if your employer is paying for you to take a degree. Because degrees in the UK are expensive. They're very expensive. Okay, so finally, let's just finish by painting a brief picture of what a business that fosters stable, learning, growing, evolving, high-performing teams look like. I'm going to talk in very general terms now. First of all, we're building capability. Our teams are getting better and better over time, which means as a business, we're capable of doing things with software that many other businesses are not capable of. So there is a competitive advantage there. We can do things other businesses can't. I know organizations, there's a company called Zulka Engineering, you may have come across them. I think they're a Swiss company, but they have offices all over the world, including Germany. And they, not only do they hire well from university, but their developers stay for a long time. I know people who've worked at Zulka for more than 20 years, for as long as I've known them. And generally still working hands-on in development, maybe in mentoring or leadership roles, but they're still hands-on with the developers. And they are very expensive. They charge a lot of money for software development because they can do things that most other consultancies like them cannot do. They have a capability most other consultants don't have. So capability is a big part of it. I'm going to answer that question now. Why is it that I can learn programming languages so quickly in just a few days? It was not the case when I started. When I started programming in the early 1980s, my first programming language was BASIC, and it took me months to get the hang of it. And that's because I wasn't just learning BASIC, I was learning programming. I was learning all these new concepts and these new skills. So it took a long time. My second language was assembly. That took a while, but not as long as it took me to learn BASIC. And then Pascal and Fortran at university. I studied physics, you can probably tell. And then C and C++ for my first jobs. And then I had to learn about databases, which I've always regretted. And then Visual Basic, which I really regretted, but that's where all the money was. And then COBOL, well, I've told you about that one already. I learned a lot about human nature from that job, but not a lot about programming. Smalltalk, Java, JavaScript, C#, the list goes on. And every new programming language I learn, as long as the concepts are familiar and it kind of feels like one of the other languages I know, it's a bit like learning Latin. Why do kids learn Latin at school? Because so many other languages are based on Latin. It helps you to learn other languages. Why should programmers learn C? Because so many other programming languages are like C. Are derived from C in some kind of way. That if you learn C, it's much easier to learn C++, it's much easier to learn Java, JavaScript, C#, and so on and so forth. So the reason I can learn programming languages so fast is because I've already learned so many of them. So not only do you get that increased capability, that upside-down pyramid team, but the people at the top of that pyramid team, despite what people say about younger developers learning faster, it's not really true. It's not really true. Developers who have a lot of experience, and particularly wide experience, tend to be the fastest learners of all. And when you have teams who learn very, very fast, this means that as a business, you can pivot quickly. If the market conditions change, if someone comes along and decides that we're all going to be doing deep learning from now on, then you can pivot to that much faster than organizations that do not have stable teams, that do not have learning teams, that do not have that upside-down pyramid of experience. You can change direction much faster. So it brings you not just increased capability in the short term, but increased agility in the long term, the ability to change direction as often as you need to. And finally, as with all of the things that I talk about, it's really what I'm about, it gives you more throws of the dice. More throws of the dice. And for anyone who's a betting person who understands that business essentially is just a throw of the dice, you're going to want more throws of that dice. You've got teams that are capable, that are ready to go anytime you need them. You just need to take your foot off the brake. More throws of the dice. And better throws of the dice. Better dice. Put it that way. Better dice with better odds. Okay, folks, I think that's my 30 minutes, which is just as well.
Thank you so much, Jason. And we learned that C is the Latin of the programming languages, which I like very much. Of course, yeah, lifelong learning and the real capital which lies in the knowledge of the teams. Yeah. So thank you so much.
Yes. No, thank you. It's like I said, first conference in a long time, face to face. If I die tomorrow, you'll know what happened.
Thank you very much.
Thanks.